Consider f of x equals 1 plus x raised to the negative 1 over x power. Now, this looks like a pretty crazy function, but there's no real reason that the function itself would be difficult to work with just because it looks crazy. Because all we're going to do is evaluate this function at different values of x. And in fact, the calculator is going to do that for us. So as long as we can type this into the calculator properly, and the way we're going to do that is just leave the parentheses around the base, which is 1 plus x. And when we do an exponent, make sure we put parentheses around this exponent so that we get everything in the exponent, negative 1 over x. So we're going into the calculator here under y equals. Just clear out any functions that you may already have and put in 1 plus x in parentheses, then your exponent, and then in parentheses again, negative 1 over x. And when you press second table set, just to make sure the settings are correct there, independent to ask, dependent to auto, then go over into table. You can type in any values you want and evaluate your function there. So if you want to evaluate that crazy looking function at negative 0.01, that's fine. We get 0.36603. And then if we do it at negative 0.001, it's 0.3677, although it says to do this to 5 decimals, so 0.36770. And at negative 0.0001, that is 0.36786. Now, looking at these values, certainly the x is approaching 0 from the left-hand side. But what are we approaching from the right-hand side? What are we approaching on the y values? They all start with 0.3. The first one's 0.34, but the next one's 0.36, and the remaining ones are 0.36. So we are sort of targeting something. So we go from 8 and then 6 on the second digit, and then we target 7. So I think we are getting closer and closer to a specific value, even though it might not be entirely clear what that is. It's certainly much easier to recognize if it's an integer, but if it's not an integer, that's okay. It can just be a decimal, and that's fine. So let's say, for now, we're approaching 0.36786. All right, then we'll check the right-hand side. So coming from the right-hand side, we'll just start plugging in values, beginning with 0.01, which is 0.36971, and 0.001, which is 0.36806. 0.0001, and that is 0.367, I guess 36790. Now, this also is sort of approaching around 0.367, but it's not entirely clear exactly what it might be approaching after that. We'd have to really go further to get it to 5 decimals. But I think we can agree that it is to 3 decimals, 0.367. If we wanted to do something a little bit more precise and just take the average of the ones we have so far, that usually makes sense. So we could take 0.36786 plus 0.36790, divide those by 2, and just say that they're approaching 0.36788, because they're probably approaching a middle value, so that probably makes sense. So the limit as x approaches 0 is going to be 0.36788. Now the next part says, estimate the value of e to the negative 1 using your calculator and enter that answer to 5 decimal places. So if I just come into my calculator and I type in e raised to the negative 1 power, it's 0.36788, which is the same thing that we just came up with. So what they're saying is this limit is actually e to the negative 1. So for this particular function, let me write it out down here. We're saying the limit as x approaches 0 of 1 plus x raised to the negative 1 divided by x is e to the negative 1 power. And in fact, if I had made this a positive 1 over x, that would have been e to the positive 1. So this limit right here is actually the definition of the value e. That's how we come up with it. So just kind of a fairly interesting situation if you haven't seen it before.